Alright, so looking at some of these story problems then. This seems to be off. 35. It talks about the equation of the vibrations of the note F above middle C is represented by the following equation. So y equals 0.5 sine 698 pi t and what does it want us to do? Determine the amplitude and the period for the function. Okay? So this in a sense is kind of review. Alright? Determining the amplitude and the period. Recall that the amplitude is determined by what value? A value, which is located where? Right out in front, what's being multiplied by sine or cosine. So in this case, what's the amplitude of this sound wave? 0.5. Okay? Amplitude would be 0.5. Okay? Remember, amplitude's always positive, so even if they would throw a negative number there, the amplitude's still always positive. Okay? Also wants you to determine the period of this function. Because it's a sine function, we use what? 2 pi over b. Okay? Period is 2 pi divided by the b value. So in this case, it'll be 2 pi divided by what? 698 pi. Okay? That 698 pi is your b value. T is your variable, remember? Okay? Or x or theta, they could use any variable they want to. In this case, they're using t for time since the note was struck on the piano. Okay? So 2 pi over 698 pi. Pi's cancel and you get 1 over 349.
Yeah.
Okay? 1 over 349. Just leave it as a fraction. What does the period represent?
The wavelength.
The wavelength. Yep, how long it takes to complete one wavelength. Okay? It doesn't ask this, but I might. So what is the frequency of that note?
349.
349, because the frequency is the period's reciprocal. Yep.
That'd be like hertz.
I believe they're talking in hertz here, yeah. Okay. The period tells you how long it takes to complete one wavelength. Okay, the frequency basically tells you how many wavelengths it completes per time unit. It's the reciprocal. Okay? So this would be the frequency. How many wavelengths it completes in one time unit. Music-wise, the lower the frequency, the lower the note. The higher the frequency, the higher the note. Okay? A little bit of music there for you. It's about as cultured as I get. Sorry. Alright? So, tomorrow, guys, question like this. Listen carefully. I give you the equation, you identify these three things. Or, I give you these three things, you identify the equation. I'd be ready for something like either one of those.
So if you
or
gave
both.
us those three,
yeah.
would we be expected to write 698, or do we have, or could we write 349?
Where at now?
For the period.
If I give you these,
Yeah.
this is what I'd be looking for my answer. For sure.
Never mind.
I mean,
So you
You can take it by 2 pi.
get it back, like, you'd have to multiply the period by 2 pi, right?
so if I gave you the period and told you to write the equation, you'd have to determine what the b value is, right? So you'd set this equal to 2 pi over b. So you'd have a proportion, right? 1 over 349 equals 2 pi over b. And how do you solve proportions? Cross multiply. When you do that, you'll get b equals 698 pi, so you know 698 pi goes up in your equation. Please don't forget to put the variable in there if you are writing the equation. Don't just write 698 pi.
You'll say sine, right?
Okay?
It's sine or
I would tell you whether it's a sine function or a cosine function, so you won't need to worry about that, Tyler.
Frequency like definitely on, or is it just, are you just using it as an example? Is it
I'm-
the first 3, 4?
I'm giving you what you need to know here, for sure, specifically, so, yeah. Yep. So I'll go ahead and tell you, one of the problems is I either give you the equation, you identify these 3 things, or I give you these 3 things and you,
Will this be our third time doing this?
this is the first time taking the story problems.
Oh, it's like.
How many store problems will there be?
There's just a few. Okay?
So this is the first time?
This is the first time for all the story problem ones, yes.
But is there a second those equations though? Is it the second time?
How many did we take the other one without?
We've taken graphs twice, and we've taken identifying properties twice as well.
Are we taking either one of those again?
Yes, yeah. That's where you've seen something like this before, but it wasn't a story problem. So this sort of problem, we're just putting on the applications.
It just gave us the numbers and stuff.
Yeah, correct. They didn't mean
I didn't
anything.
have a story, so.
Correct, yes. There.
I'll just ask you for this time problem, can you add, like, 2 numbers for the, it's number 12, or on page 363.
363, number 12.
Yeah, can you add those 2 to get the amplitude? Since you're multiplying already by the sign. And the-
No, that 49 is the vertical displacement.
Oh, it's just
Oh,
a.
That's your D. That's your D value.
Oh, okay.
They just put it in the front instead of the back.
And then
So-
for the pi over 6, would you just distribute and then?
I would.
Your period and then that's your function?
Yes. So in that one, 28 would be your amplitude. Pi over 6 is your B value. And then whatever, and then you'd have to, I'd want to distribute it and then solve to find my phase. I'm not going to ask you for the phase shift. I'm going to ask you more of a question like they do with it. I'll ask you to get some information from that equation by plugging in numbers.
Would you expect us to pull out like a common factor? Like if we were putting this back into an equation?
No, I'd simply, I mean, that question is what I would ask. Compare the average monthly temperatures for April and October. Well, how do you find the monthly temperature for April? April is the what month? 4th month, so plug in a 4 for T and get your Y value. Plug in what for October? 10. Plug in a 10 for October and see what you get for your Y value. That's what I'd expect in a problem like that. Tyler?
Well, I did this one earlier, and it's like an even problem, so I can't like go back and check it. So can we like go over the?
Number 12?
Yeah.
Okay. Let's see if we can get our answer to number 12 then. I'd make sure I'm looking over all these story problems, guys, because all the ones on the test are definitely ones that are in that group. But I'm not telling you which ones.
Is this 360?
This is number 12 on page 363. 12 on page 363. It says, this sine function models the average monthly temperature for Omaha, Nebraska. In this equation, T denotes the number of months, with January being represented by the number 1. Compare the average monthly temperature for April and October. Well, T is your months, and January represents month number 1. To figure out the average monthly temperature for April, you're going to plug in a 4, right? Now, notice we're in radians here, so you better get your calculator into radian mode. We're plugging in a 4 for April, right? 4 minus 4 is 0. Times pi over 6 is still 0. Okay? So what I'm simply going to do is I'm just going to type in 49 plus 28 sine 0. I could probably do this one in my head because I know what the sine of 0 is equal to. Okay? But 49 plus 28 times the sine of 0, and that gives me the number 49. So the average April temperature in Omaha, Nebraska is 49 degrees. Now to find my average monthly temperature in October, I'm going to plug in a 10 for T. 10 minus 4 is 6. What's 6 times pi over 6? Pi. So now I'm going to type in 49 plus 28 times the sine of pi. And also 49 degrees. Okay? Shouldn't be too shocking because if a sine function represents the average monthly temperature, well, if you think about it, in January, it's on its way up, gets probably to its high point in August or July, and then starts coming back down and just repeats itself over and over and over again over many years. So it wouldn't surprise me that the average temperature in April is probably similar to what it is in October.
Yeah, I looked at it and I saw I got the same answer for both.
And that just low red flag because you thought you were doing something wrong, but nope, you were good. Okay? How long is the period of this function? Don't do any math. Think.
2 pi over 6.
Think. Don't do any math. Don't do any math. Think. What does this represent?
12 months.
What?
12 months.
Why?
Because that's how long.
That's how long
Everything
1 year
Is
is.
it going to repeat itself after every 12 months?
No.
The pattern? January monthly temperature, then repeats itself when it gets to January again, January again. 12 months. 12. Now, what's 2 pi divided by pi over 6? 12. Okay, but I wanted you to just think about it logically. How often do you think the pattern of temperature repeats itself? Every year. Okay, 12 months.
Could we have said 6?
Huh?
Could we have said 6?
No.
Why? That's when it's.
That's like only half.
That's half the period, bro.
Never mind. That's the question.
Yeah.
Okay. What else?
How does it do this?
Because I'm nice, how about page 391, or excuse me, 393, number 13.
Would that one maybe be on the 393?
393, number 13.
Oh my. Also, the average monthly temperature is the same.
All they give you in this problem are the average monthly temperatures for Honolulu. And you got to answer a bunch of questions about it. On your graphing calculator. Yep.
What are we going to do?
We need to be in radians.
You need to be in radians. And I would get in the habit of almost always being in radians unless they give you pictures of triangles and you specifically see degrees in them. It's just in general. It's nice when they give you an equation and you can answer a bunch of questions from that equation. Here they just give you data, no equation. What tool does the graphing calculator have that can help you determine an equation from a bunch of data?
Linear.
Regression is the actual one. In stats we've done linear regression, but if you go stat, calculate, and you start going down a little bit to ABC,
Wait, where?
stat, calculate, start going down.
I don't have ABC. Where's stat?
Linear regression?
You started going down.
Yeah, I'm sorry. Cubic regression.
There's ABC. You went past it.
Oh, these. I was thinking.
You should find a sine regression. Did everybody find sine regression?
They're so
Stat, go over to calculate, start hitting the down button until you find sine regression.
I have x equals x stat, y equals y stat.
Oh, I also got smart.
Sine regression.
Oh, you have some.
Zero self-esteem.
I don't know. I'm gonna have to mess with it. Or you're gonna have to just use a different one, Jake. You enter the data in your list, then you tell your calculator to do sine regression of L1, L2, and it'll give you the equation.
Where do I go?
What's-
L1, L2, and
What's
that
that
edit?
iteration?
Wait, what's iterations? Iteration.
It's
Put it
that
at 1.
Why's there?
Yeah, well, it's that edit, right? To punch in.
So all I'm doing is answering questions. Now I'm gonna shut this off.
Regression.
What?